Hello everyone, welcome to my YouTube channel. My name is Evidence. In today's video, we are going to be talking about SQL LAG Window Function, and we are going to be going through a detailed explanation with examples and code. I've written a blog post on this, so I'm just going to use it as a point of reference as we go through this tutorial. And over here on the right side, I have DB browser for SQLite. This is where I'm going to run the code. So for today's video, I am going to show you the syntax of SQL LAG Window Function. Then I will explain what the syntax means. I'll show you multiple examples of using SQL LAG Window Function, and then I'll use those examples to explain SQL LAG Window Function in detail, and finally I will end with a use case. The reason why I include use cases in my videos is because a lot of times it's easy to learn a new technology or to learn something new, but actually knowing when and how to use it is really important. So we're going to cover one use case for SQL LAG Window Function. So to begin, the simplest way to explain SQL LAG Window Function is that it gives you the previous value from the current row. And this seems very vague and not very clear what that means, but don't worry, as we go through this video, it's going to make a lot more sense. So let's begin with the syntax. First of all, the thing you need to know is that if you know SQL LEAD window function, then you already know SQL LAG window function. SQL LAG window function is like the opposite of the SQL LEAD window function. So if you already know SQL LEAD window function, you can turn off this video because you know everything you need to know about SQL LAG window function. If you want to learn about SQL LEAD window function, you can go to this blog post that I created on SQL LEAD window function, and I have a video here as well, and I'm going to put the link to this in the description below. But let's begin with SQL LAG syntax. So I'm going to copy this and I'm going to put it over here in SQL, and I'm going to explain it step by step. But before that, let me go ahead and open the database I'm going to be using today for the video. If you want to follow along and you do not have DB browser for SQLite already, you can go to this blog post, which I will link below, and it shows you how to install SQLite on Windows and Mac. And to get access to the database that I'm going to be using today in this tutorial, you can join my free technical resources page. Here I have a lot of resources, including the employees database, which is what I'll be using today. That's how you get access to DB browser for SQLite to follow along in this video. So with that being said, let me go ahead and open the database. So let's begin by looking at the syntax. I'm going to paste it here because DB browser for SQLite has syntax highlighting, and it makes it easy to kind of see the different parts of the syntax. So let's begin with lag. Lag is just the SQL keyword to identify what function you want to run. That's what lag is. And return value is like the column or the expression that you want to use as the basis for your calculation. And this return value is going to make a lot more sense once we actually start looking at some examples. And the next one is offset. Basically, how many rows from the current row you want to start returning values. So normally SQL has an offset of 0, like that's the default, which means when you run your query, SQL will return the value starting from the first row, right? That's what offset of 0 is. But in SQL LAG window function, the default value for offset is 1, which means when you run your queries, the query will start returning values from the next row, which is row number 2, the next row. So basically what you need to remember is that offset basically says how many rows from the current row should I start returning values. And offset will make a little bit more sense once I show you an example. I have a couple of examples here on how to use offset. And default value basically says like if there is no value in the previous row, what should be returned, right? So like I said earlier, SQL LAG window function gives you the value in the previous row, but if there's no value in the previous row, what value should be returned? That's what default value is, and the default value is null. The default value is null, but you can change it, like you can replace this null with a string or a number. And then we have the over keyword, and then we get to partition. So partition is basically how to subset your data. So whenever you think of partition, think of it as creating subset of your data based on a single category or two categories. Usually we do partition by and then column name and then another column name, and the categories in that particular column will be used to group your data into subsets. And you can have more than one column in your partition. Your expression here could also be a query as opposed to a single column. And then we have order by. Order by is exactly what it sounds like how should the data be ordered. Just ascending and descending. Ascending is the default, but you could specify descending. And you can have more than one column in your order by clause. Also, order by, like LAG window function, is not an order dependent function, which means that you do not need to have order by clause here for the LAG window function to work. Like even if you don't use order by, LAG window function will still work. So that basically explains the syntax of LAG window function. And if you're still confused, don't worry, we're about to get into examples. And I like to take the time to explain the syntax up front so that once you actually start writing code, it will make more sense. So the first query we are going to run, the first example we are going to look at is like using all the default values. So in this situation, in this code, I'm just going to copy this code and I'm going to paste it here. And basically here I am using higher date as a return value, right? And I'm using 1 as the offset. So the default value for offset is 1 in LAG window function, which means so I don't need to specify this. Even if I don't specify it, the offset is still going to be 1. And then it says over, and then I don't have any value for partition, and I just did order by higher date. And then undo as higher date previous. So basically this entire LAG window function, I named it higher date previous. So when I run this, it's going to show up as higher date previous column. And this is called a window function because of the partitioning. And the partition, when you use partitions to group your data into a subset, each subset is called a window. And when in this situation, like when partition is not defined, then the entire database is treated as a single partition. So let's go ahead and run this and look at the results. And there it is. So let's use this result to explain LAG window function real quick. And what we have here is we have null, right? Because there's no value in the previous row. And then we have on row number 2, we have this value here. If you see this value right here matches the value you see right here in original higher date, and the value right here matches this value, and the value right here matches this value, and this is the window function column. So that's what LAG window function does. It gives you the value in the previous row, and that is why the offset is 1 as well, because if offset was 0, then it will give you this value, but with an offset of 1, which is the default value, gives you 1 row above your current row, 1 row above your current row. That's your lag value. Let's go ahead and look at another example. So the next example is same thing, but this time I'm gonna use an offset of 2, and this is basically to demonstrate how offsets work, and you see what I mean in a second. Let's go ahead and copy this, and right here is the exact same query as above, but this time I have the offset as 2. So remember, here the offset is 1, and because that's the default value, you don't have to specify it. But what I have here is an offset of 2, and you're gonna see how that differs. So let's go ahead and run that. And what you see right here is, let's look at row number 3 here. The value here is the same value that's 2 rows above. The value here is the same value as 2 rows above. The value here is the same value as 2 rows above. That's because we've defined the offset as 2. So with an offset as 2, it's going to give you 2 rows from your current row, right? With an offset of 5, the value is gonna come from 5 rows from your current row. Speaking of 5, let's go ahead and look at another example. This example is the same one as above, but this time we are doing an offset of 5. Let's go ahead and run this. And there we go. We have an offset of 5. We have a bunch of null values. And then if you look at row number 6, the value here matches the value here. And value here matches the value here. So I think you kind of get the idea of how offsets work. And you can use that to your advantage depending on what query you're running and working with. Now that we've gotten a good idea of how return value and offset work, let's go ahead and look at partitioning. We are going to come back to default value in a minute, but first let's go ahead and look at partitioning. And like I said earlier, when partitions are not defined, then the entire code is treated as a single partition. But before we get to partitioning, I wanted to show you what I said earlier. So earlier I told you that lag window function is not order dependent, which means you don't need the order by clause. I just wanted to demonstrate that real quick. So if you look here, this is the query I had before, and it said Charles is number 1, Louis is number 2, Karen is number 3, and that's because I'm ordering by higher date descending, and we have 2000 right here and 1999. If we remove the order by clause, this is still going to work, but it's no longer going to be ordered. So now we have Stephen as number 1, Nina as number 2, Lex as number 3, and this value is different from what we had earlier. This value is different from what we had earlier. So I just wanted to show you that you don't need to specify the order by clause for this to work. Let's go ahead and uncomment that. Let's look at partitioning. So I'm just gonna copy this code. So basically it's the same code as the one above. I'm using the default offset value of 1, and I'm using null as the default value, and I'm doing partition. This is the only new thing, and here I'm doing partition by department name, and then I'm doing order by higher date. And like I just showed you, you don't need higher order by right here. You can do it without order by. So and then I'm doing an inner join to department column, department table. Let's go ahead and run this, and this is what we get. So partition, like I said earlier, partition breaks your data into subsets, and each subset of data is called a window. So let's look at the department. That's what I used to break it apart, to subset the data. And what we have here is we have accounting, we have administration, we have executive. As you can see, like all the departments are combined together, are put together, right? That's what partitioning does. And the key thing you need to remember about partition is that This lag function is applied to each subset of data. So it's applied to each partition, each window. And at the end of that particular data subset, the lag window function stops and starts over. So let's look at this executive and finance so to make a lot more sense. So if we look at the executive, right, and we look right here, this is null because there's no value in the previous row for executive department. And if we look at finance, this is null because there's no value in the previous row for the executive department. So this right here is the first row for the finance department, and each department is treated as its own subset data unit, and at the end of that data unit the function starts over. That's why you see so many nulls here, right? And then right here on row number 8 there's value here, and then because there's value here in row number 7 for finance, and there's value here, and because there's value here. And then once we come to the end of the finance row, there's value here on the last row for finance, and then because there's value here, but there's no value here in the human resources department because this is the beginning of a new unit, the beginning of a new window, right? The beginning of a new data partition. So the function, the lag window function, is going to start over. That is a key thing you need to remember about how partitions work. So now that you understand how partitions work, well, at least I hope you understand how partitions work, so you can kind of see how it's being used. And I want to call your attention to these null values. So as you can see, when there is no data in the previous row for this particular partition, it returns null. Same here, returns null. But you do not have to return null. You can return a value for null, right? So this null right here is coming from default value right here. You can replace null with a string or a number like I mentioned earlier. So let's go and look at an example of replacing this null with strings and numbers. So I'm just gonna copy this code here and let's put it here, and I'll explain it in a minute. So basically here, instead of using the default value, I'm putting in not applicable for default value. And the fact that I put 1 here is very important, right? Because if we go up here to the original syntax, we have return value, offset, and then default value. SQL is expecting the inputs in this order. It's expecting return value here, offset here, and default value. If you put return value here and you do not specify an offset and you specify a value for not applicable, it is going to assume that the value you specify for default value is actually the offset value. So if you are going to define default value for your lag window function or your lead window function, you have to make sure you specify the offset as well, even if the offset is 1, which is the default value for offset. So with that being said, let's go back to this code. We have the higher date, we have offset value, then we have not applicable. So now it's the exact same code as above, but now it is going to replace nulls with not applicable. Let's go and run this. And there we go. And all the nulls has been replaced with not applicable. And like I mentioned earlier, you could also do a number instead of a string. So I'm just gonna replace that not applicable with 100. And right now all the null values is replaced with the value of 100. So that is lag window function for you. But before you go, I want to show you one use case. And like I said earlier, it's cool to learn new stuff, but actually knowing when to use it and why you may want to use this cool thing is very, very important. So let's go ahead and take a look at that. So here I'm using a CTE, and I know some people have a problem with CTEs, but personally I love CTEs. I think they are great. And this is how you define a CTE. Like from here, width to this is the CTE. Actually, no, from this to this is the CTE, right? And this is the end of the CTE, and this is the name of the CTE. Hiring is the name of the CTE. And basically, first I am running this query, right? And I'm saving it to this CTE under the name variable hiring, and then down here I am selecting everything from this hiring CTE, and then I am doing a subtraction between the hire date and the hire date previous. So Julian Day is the keyword that DB browser for SQLite uses to do date difference. Different database management systems uses different keyword or different method for doing date difference, and Julian Day is how DB browser does it. So that's what this is. And basically what it's doing is it's going to calculate the difference between the original hire date and the previous hire date, basically like how many days between employee hires. And here I'm not using any partition, so it's going to run this for the entire data set. Let's go ahead and run this. And right here, as you can see, it says 92. So 92 is the amount of time between when Jennifer was hired and when Stephen was hired, right? And then we have 735. 735 is the amount of time between when Nina was hired and Jennifer was hired. So basically what it's doing right here is it's doing this date, which is Nina's hired date, and minus this day, right? Minus this day. This is the same value as this one, which is Jennifer's higher day, when you get 735. Same here is doing the difference between this day and this day, and this date corresponds to when Nina was hired. So that is one use case for SQL LAG window function, calculating the date difference. The same thing applies to lead window function. Like you could also do this in reverse and use lead window function, and you switch out the values here. So that is one use case. If you think of more use cases, you can put them in the comment section below. I would like to know how you are using LAG window function in your day-to-day work. And if you want to get access to all this code, you can come to this blog, which I put in the comment section below, in the discussion section below. Also, if you want to get access to SQLite, you can go to this blog post, which I'll put here, DB browser for SQLite. And you can follow me on YouTube. I assume that's where you're watching this, or on LinkedIn, GitHub, and Twitter. And I'm gonna put the link to my socials in the comment section below. And like I mentioned earlier, feel free to come here and get access to my free technical resources, and you get access to this employees database and many other resources. So when I create technical content like this, I put them all in the same place because it makes it easier to just keep track of what I have out there. You can also join my tech newsletter, and whenever I create new content, I kind of send out an email just to let people know, hey, I created this new content, go check it out, and I hope you like it. Anyway, that's it for this video. Thank you for watching, and I'll talk to you on the next one. Bye.